Okay. I think we ended our discussion with this yesterday. Tama ba? Okay, so let's see. Okay, so yesterday we were talking about the different equipments, glasswares that we usually use in the laboratory to measure things, measure mass through analytical balances. We measure volume through beakers, graduated cylinders and such, and pipettes. And all of these things are necessary to create uh, solutions uh, that are used in particular laboratory experiments. Okay, so yesterday we also talked about uh, the ways on how to create solutions. No, it's either you can prepare it by preparation of stock solution, which actually is you preparing a solution from the original non-diluted or let's say concentrated or uh, pure substance. Okay, so you have their preparation of stock solutions and preparations of solutions by dilution. Now, dilutions, of course, is when you try to lessen the concentration of a solution, usually from a stock solution. Okay, and when you dilute, it's vital for you to know first the concentration of the original or the stock solution and the concentration of and the volume of the original solution. Okay, and so I introduced to you the formula COVO is equal to CDVD, or the original concentration multiplied with the original volume is equal to the diluted concentration multiplied to diluted volume. Okay. Now, I have here some problems, work problems that uh, will help you understand how these things are prepared in the laboratory. So here the problem is, can you read it? Kaya ba? Okay. So the problem is, describe how you would prepare the following three solutions. Okay. So you have here three setups. A, you have 500 ml of approximately zero point 0.2 molar sodium hydroxide using solid sodium hydroxide. So the solid sodium hydroxide is the one is the origin is the concentrated form of sodium hydroxide. Sodium hydroxide is highly reactive when it comes in contact with water. Letter B is 1 liter of 150 parts per million copper using copper metal, and 2 liters of 4% volume per volume acetic acid using concentrated glacial acetic acid. Okay, so let's have them one by one. First, again, 500 ml. How would you prepare in the laboratory 500 ml of approximately zero point 0.2 molar sodium hydroxide using solid sodium hydroxide? So, if you have a solid sodium hydroxide, uh, first you have to know to get the molecular weight of the substance, sodium hydroxide. So, for the molecular weight, you have one atom of sodium, one atom of oxygen, one atom of hydrogen. That's 1 times 23 plus oxygen 16 plus 1 for hydrogen. These are all the atomic weights. is equal to 40. Okay. Now this 40 here is uh, can be used to get the molarity, right? So the molarity formula is weight of solute in grams over molecular weight times 1,000 over the volume in ml of the final product. So what you are asked is to get or to prepare 500 ml of zero point 0.2 molar sodium hydroxide. So basically, what you want to do is to know how much of solid sodium hydroxide do you need to prepare 500 ml of solid sodium hydroxide. So to discuss how you got here, or okay lang? Okay lang, no? Okay. Since you now have your molarity, alam mo, 0.2. You also know the molecular weight, it's 40. And you know how much do you need to prepare, 500 ml over 1,000. So if you calculate this, you'll get 4 grams of solid NaOH. Okay? So in the laboratory, what you will do now is to weigh 4 grams of solid NaOH. Okay? And since it's just 4 grams, you can't use just any other weighing scale. You have to use an analytical balance. Huh? Uh, and what you will do is you add approximately 500 ml of water. No? If you do that, you'll get 500 ml of zero point 0.2 molar sodium hydroxide. So this is how you do it. No? So you first weigh your 4 grams of pure solid sodium hydroxide, and then you add it first to enough water just to dissolve it before to a volumetric flask that is capable of holding up to 500 ml of volume. Okay? So whatever volume of water you added here at first, no? Kailangan mo lang dagdagan enough to make 500 ml. You follow? You follow? Okay lang? So that's again, the problem is how would you prepare 500 2 molar sodium hydroxide if you only have a solid sodium hydroxide? So first, you measure how much sodium hydroxide is needed for you to prepare it, and then mix it with distilled water. Question? Okay, on. Let's continue. How about for letter B? For letter B, you are asked to prepare 1 liter of 150 parts per million copper uh, using copper metal. Okay. So since what you need to have is um, concentration by parts per million, so you use this particular formula. Again, guys, these formulas were already given to you and are already familiar to you based on our previous discussions, correct? So you have parts per million. So the formula is weight of solid in grams of solute over volume of solution times 10 to the 6. And since uh, you are only given copper metal, what you want is actually the weight of the solid or the solute metal, right? So again, you have to manipulate this formula such that the weight of solute is isolated. Therefore, you have weight of solute. Basically, you just multiply both sides with volume of solution, no, and then divide it over 10 to the 6, right? So you have 150 parts per million, that's part of the given. 1000 ml of course, equivalent to 1 liter, over 10 to the 6, giving you 0.15 grams. Okay? So now you have the amount of copper metal needed for you to prepare the 150. Okay? So to prepare the solution, we measure dissolve use a strong acid and gently heat until completely dissolved. The resulting solution is poured into a 1 liter uh, poured into a 1 liter volumetric flask. The beaker is rinsed repeatedly with small portions of water, which are added to the volumetric flask. This process, which is called quantitative transfer, ensures that the copper is completely transferred to the volumetric flask. Finally, additional water is added to the volumetric flask, calibration mark. Okay? So, pag sinabi mong volumetric flask is a flask that has calibration mark. So you are already guided how much volume of water or whatever solvent that you need. No? You are being guided how much you have to add to reach that particular volume. No? Yun yung volumetric flask. Parang ganito. Ito yung guide mo. No? So you add enough of the solvent para ma-fill hanggang doon mark ng volumetric flask. That's example. Okay? So basically, ang gagawin mo dito is you weigh 0.15 grams and then you add your 0.15 grams of copper into small portions of concentrated citric acid. You heat it up using a heat source. It could be a Bunsen burner, an alcohol lamp, or even a hot plate. No, any um, heat source that could boil this particular mixture. And once it's all dissolved, you can clearly see there na ang copper ma-dissolve siya, mawala siya, no? And then transferring it to a 1,000 ml or 1 liter volumetric flask, and then you transfer it there. So obviously it's not yet 1 liter, no? So what you have to do is you put water here doon sa flask kasi most likely meron pang naiwan dito na copper. Tapos i-whisk mo siya, swirl, swirl, swirl para matanggal mo yung nakadikit sa beaker, and then you pour it again until you reach the mark of the volumetric flask. This is how you do it in the lab. Okay? And lastly, for letter C, no, 2 liters of 4% volume per volume. So that's a liquid and liquid acetic acid using concentrated glacial acetic acid. Now, 4% acetic acid is actually the acetic acidity that you have in your commercial vinegar. No? Halimbawa ka ng dato puti soy sauce, dato puti soy sauce, dato puti vinegar, or whatever vinegar in the market. Usually, if you look at the label, it says it would acidity. That means uh, from a pure acetic acid, we call it glacial acetic acid because it's so concentrated that it would form crystals that looks like glaciers, no? Looks like ice. That's why it's called glacial acetic acid. That glacial acetic acid is dissolved in enough water to form 4% acetic acid, which is basically nga, your vinegar. So since you're given a volume percentage of 4%, no, you could use this particular formula. Again, all of these formulas were already given to you in our previous discussions. So volume of solute over volume of solution times 100. Okay, so you have 4%, 4%. That's the concentration that you want, percentage of acetic acid, times 100 weighted cylinder to transfer 80 ml of glacial acetic acid. So you need to dissolve, or you need to mix 80. So basically what you're doing is you get 80 ml volumetric flask and enough water until such time you reach 2 liters or 200 ml. This now, this is 100% acetic acid. This is around, okay lang. In the lab, if we can do this in the laboratory, no, you would really smell the scent of vinegar. Any question, guys? Sige. Uh, and another problem here is a laboratory procedure calls for 250 ml of an approximately zero point 0.1 molar solution of ammonia of concentrated NH3 having molarity of 14.8 molar in the laboratory. So to do that, remember, you are given a stock solution with known concentration, okay, 14.8 molar. And you need it to be zero point 0.1 molar, right? With 250 ml of 250 ml volume. So remember the formula, original substance, the stock solution, that's 14.8 molar. You don't know the volume of the original that you need, no? So that you could prepare a zero point 0.1 molar 250 ml NH3. So basically, again, manipulate your formula so that you could isolate what you need. In this case, concentrated NH3. So here, times 200 ml over 40, end up with the 2.7 ml of the original 2 from 14.8. If you want it to approximately 0.1 molar, we can measure 1.7
Open ang camera for attendance.